Most people think the artificial intelligence revolution just kind of lives inside a chatbot. You type a prompt and boom, this seemingly effortless magic happens right in front of you. You get a brilliant answer on your screen in seconds, or maybe a stunning image, or you even ask an AI to write some complex code. The whole interaction feels completely weightless, invisible, and totally instant. But actually, there is a massive, incredibly tangible reality supporting every single one of those digital moments. So, welcome to this explainer. Today, we're going to unpack the hidden, heavy physical world behind this whole phenomenon. Okay, let's dive right into this. It's a question we honestly rarely ask ourselves. When you hit enter on your phone, it's so easy to just imagine your request floating up into this ethereal, invisible cloud. But we really need to shatter that illusion right now. Your AI-generated image doesn't come from a fluffy cloud in the sky. It comes from a colossal, hidden physical infrastructure that is operating nonstop behind the scenes. We are talking about a totally wild world of warehouse-sized buildings, millions of advanced computer chips, thousands of miles of physical cables, and just staggering amounts of electricity. So let's actually break down the physical journey of just a single prompt. It happens in 3 pretty astonishing steps. First, your request leaves your phone or your laptop and physically travels through fiber optic networks at basically the speed of light. Second, it arrives at a highly secure data center where thousands of specialized AI chips, you've probably heard of them, GPUs, perform billions of mathematical calculations in parallel just to process that one prompt. And third, that generated answer is sent all the way back through those same cables right to your device. And this entire immense physical journey, it happens in literally seconds. Moving into section 1, the great shift from cloud to supercomputer. To really wrap our heads around how we got to this point of instant, massive computation, we have to look at how AI completely transformed traditional computing. See, for decades, the old cloud was basically just a digital warehouse. It was built to store websites, business applications, your emails. It basically just replaced the server closet in an office building. But the AI cloud, that is a completely different beast. Training modern AI models requires resources that would have been flat out unimaginable a decade ago. Instead of just housing a bunch of independent servers, companies are now deploying clusters that contain tens of thousands of advanced GPUs, and they're all wired together to act as one single massive supercomputer. And why on earth do they need to act as a single supercomputer? Well, it's because of the sheer volume of math involved. These advanced AI chips are performing trillions of mathematical calculations every single second. Yes, trillions with a T. They have to process enormous data sets to teach AI systems how to recognize patterns, understand human language, generate those images, and solve incredibly complex problems. It's a level of heavy computation that requires a highly engineered, very specific environment just to survive. Which brings us to section 2, engineering the megacentered. Building a modern data center is vastly more complicated than throwing up a conventional office or traditional warehouse. Operators are juggling this crazy, multifaceted set of challenges. They have to find locations with massive, hyper-reliable electricity access. They often seek out cooler climates so the outside air can literally help with efficiency. They're integrating advanced liquid cooling, ultra-fast internal networking, specialized massive data storage, and of course, super strict cybersecurity, because these facilities hold some of the most valuable intellectual property on the planet. But let's actually zero in on one of the most pressing physical challenges on this whole list. The heat problem. Think about it. When you pack thousands of advanced processors into a room and demand that they perform trillions of calculations a second, they generate an immense, blistering amount of heat. If temperatures rise even slightly too high, performance completely plummets, and expensive hardware literally begins to fail and melt. This is exactly why the industry is rapidly transitioning away from traditional air cooling, like those massive air conditioners, to highly efficient liquid cooling technologies. They actually have to pump liquid directly to the densely packed processors just to whisk that heat away fast enough. So the absolutely crucial point here is that running these chips and running the cooling systems needed to keep those chips from melting takes power, a lot of power. A large AI data center today can easily require hundreds of megawatts of electricity. To put that into perspective for a second, some of the newly proposed AI facilities are expected to consume as much power as an entire medium-sized city. And they don't just need it sometimes. They require this power 24 hours a day, 7 days a week without any interruption. This absolutely insatiable demand for electricity is forcing data center operators into some deep partnerships with utility companies. They're having to explore massive new energy generation methods just to keep the lights on. They're investing heavily in renewable energy, in advanced battery storage to capture and hold it all. And fascinatingly enough, this boom has sparked some very serious renewed interest in nuclear power, seeing it as a long-term, zero-carbon solution capable of providing the constant, massive baseline power that these AI infrastructures demand. But power is just one piece of the puzzle, right? Inside these buildings, thousands of processors have to communicate with one another continuously to train an AI model. Even tiny, microscopic delays in data transfer can completely ruin training times and destroy efficiency. Because of this, companies are pouring billions into zero-delay networking. Specialized equipment from companies like NVIDIA and Broadcom is honestly just as important as the chips themselves, because it allows enormous clusters of GPUs to operate perfectly in sync, essentially behaving as one giant, unified machine. Let's look at Section 3, the infrastructure ripple effect. When you start spending hundreds of billions of dollars on land, power, cooling, and chips, the impact extends far beyond just the tech world. This tech boom is actively dragging entire legacy industries into a historic investment cycle. It's creating this powerful economic engine across multiple sectors. Real estate developers, they're pivoting to create dedicated data center campuses. Construction firms are starting to specialize entirely in these mission-critical facilities. Energy companies are being forced to invest in huge new generation capacity, and engineering firms are completely booked up designing these incredibly complex liquid cooling and electrical systems. Entire local economies are literally being reshaped by the sheer demand for the physical buildings that house artificial intelligence. Section 4, Power, Grids, and Geopolitics. Naturally, rapid, unchecked expansion of this magnitude creates some serious friction. As we pull the lens back, we really have to look at the global and environmental implications of this boom. The macro challenges we're facing are going to shake the future of AI just as much as any cool new software breakthrough. I mean, can our aging electrical grids actually keep pace with this staggering demand? How much can operators realistically improve energy efficiency? What happens when these massive data centers need incredibly high water usage for cooling in regions that are already facing severe drought? And how do governments balance the need to quickly permit these facilities without compromising vital environmental standards? These are massive, looming macro questions, and the industry is scrambling right now to answer them. Because the stakes are so incredibly high, geopolitics has aggressively entered the frame. Advanced computing capacity is no longer just some commercial tool. It is viewed by countries all around the world as a critical strategic resource. Governments are heavily encouraging and very often subsidizing domestic investment in semiconductor manufacturing, cloud infrastructure, and high-performance computing. Think about it. Data centers have evolved from simple digital warehouses into strategic national assets that literally define a country's economic competitiveness on the global stage. Looking forward, we find this fascinating loop starting to emerge. The very artificial intelligence that demands all this massive physical infrastructure will likely be the key to managing it. In the near future, we're going to see AI optimizing its own physical home, managing that complex power consumption dynamically, predicting equipment and cooling failures way before they actually happen, and allocating computing resources perfectly just to squeeze every single ounce of efficiency out of these mega centers. Let's see how this all builds into a broader historical context, because it's pretty revealing. History almost always celebrates the products people use, but rarely the infrastructure that makes them possible, right? The Industrial Revolution was built on the back of physical railroads and massive power stations. Well, the AI revolution is honestly no different. It may seem like pure magic on your phone, but it is built squarely on massive data centers and endless networks of fiber optics. Data centers are truly the foundational railroads of our modern age. There's this great quote from our source material that really hammers the reality home. It says, "The AI revolution may appear digital. In reality, it is built on concrete, steel, silicon, and electricity." Behind every translated sentence, every discovered protein structure, and every generated image, there is an enormous physical network of buildings, cables, processors, and energy systems working around the clock. It completely changes how you look at the screen in your hand, doesn't it? The heavy, physical reality of artificial intelligence is hiding in plain sight, scattered in massive compounds all across the globe. So I want to leave you with this question to think about. Next time you type a prompt and watch that seemingly effortless magic unfold, will you just see the invisible pixels, or will you see the massive power plant, the cooling systems, and the millions of miles of fiber optics working furiously behind them? Thanks so much for joining me on this explainer, and keep exploring the systems that run our world.